as the perceived effect, and to which you are exploring the possibility of finding significant relationships or associations in those uh, independent and dependent variables. So I have here another video lecture, an input on the assumption. So first, for this afternoon, we are going to have the assumptions on research, the bivariate, because we don't have assumptions for the descriptive only. We just need to have assumptions in the bivariate level of data analysis. So also the assumptions for t-test, and we are going to discuss also correlations. Okay. Now I'm going to share screen for the video on assumptions. This is about assumptions, both research assumptions and statistical assumptions. These are important in the conduct of social science research. Now, the research assumptions, it's first of all context bound. So what is the context that the research is being conducted, where it is conducted, what is the cultural milieu in that particular location, and the people involved. That's important consideration. Research is based on inductive forms of logic, that is from the specific to general, or from simple to complex. Categories of interest may emerge from informants, that is internal, or be used to frame an understanding, that is external, from the researcher. Whether it is appropriate to use various statistical tests depends on the characteristics of the data being analyzed. Basic assumptions about the data must be fulfilled for the test to be meaningful. Now, assumptions for parametric tests is that before conducting any parametric analysis, explore the data to ensure that certain assumptions are met. The parametric tests include some of the most commonly used analytical tools to compare groups of data with continuous variables. We know how different is continuous from discrete variables, like age is a continuous variable. Okay, measurements are continuous, weight continuous. So it all depends on the characteristics of the data. Now, a two-sample t-test, we know that there are other types of t-test, like there's the paired t-test, right? So this one, the two-sample t-test is used to test whether or not the means of two populations are equal. This type of test makes the following assumptions about the data: independence, normality, homogeneity of variance, and random sampling. Now, as to independence, the observations in one sample are independent of the observations in the other sample. So this should be two different samples. As to normality, both samples are approximately normally distributed. Homogeneity of variance, both samples have approximately the same variance. Remember variance? It is one of the measures of dispersion, right? That after variance, you compute standard deviation, which is just the square root of variance. So how far, or it's the distance uh, of other elements from the center of the data. So random sampling, both samples were obtained using random sampling method. We know there are many ways to conduct random sampling. If one or more of these assumptions are violated, then the results of the two sample t-test may be unreliable or even misleading. Now, the first assumption on independence. So in detail now, we are going to discuss this. So in here, the two sample t-test makes the assumption that the observations in one sample are independent of the observations in the other sample. This is a crucial assumption because if the same samples appear in both samples or the same individuals, then it isn't valid to draw conclusions about the differences between the samples because you're comparing the two same people. So, how to check this assumption? The easiest way to check this assumption is to verify that each observation only appears in each sample once, and that the observations in each sample were collected using random sampling. So as a researcher, you know how you did that, how you did your sampling. So what to do if this assumption is violated? If this assumption is violated, the results of the two sample t-tests are completely invalid. In this scenario, it's best to collect two new samples using a random sampling method and ensure that each individual in one sample does not belong to the other sample. As you can see, this is not good, right? Because it takes time and, of course, budget, especially if your sample is 300 and you are going to repeat that. Now, as to the assumption 2 on normality, a two-sample t-test makes the assumption that both samples are approximately normally distributed. This is a crucial assumption because if the same samples are not normally distributed, then it isn't valid to use the p-values from the test to draw conclusions about the differences between the samples. Okay, how to check this assumption? If the sample sizes are small, that is below 50, then we can use a Shapiro-Wilk test to determine if each sample size is normally distributed. If the p-value, that is the result of the computation, is less than a certain significance level, then the data is likely not normally distributed. Now, if the sample sizes are large, then it's better to use a QQ plot to visually check if the data is normally distributed. So that is how a normal QQ plot looks like. Now, if the data points roughly fall along straight diagonal line like this, in a QQ plot, then the data set likely follows a normal distribution. You can do this very, very fast in a statistical package for social sciences software or the SPSS. That's, that is software that I've been using since the early 90s, actually. But then that time, that was still in a programming mode, that is in this operating system mode. Unlike at present, wherein it's Windows based and you just need to click, 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 and it's fast. But you can also do this checking of the assumptions using Excel, but it's very tedious. Um, what to do if this assumption is violated? If this assumption is violated, then we can perform a Mann-Whitney-U test. So mean to say, it's not that your data becomes unusable. No, you can just use the two sample t-test, but you can still perform a Mann-Whitney U-test, which is considered the non-parametric equivalent to the two sample t-test, and does not make the assumption that the two samples are normally distributed. So it's just about what the appropriate statistical tool you can use based on the assumptions, whether it's followed or satisfied or not. Now, as to the third assumption on homogeneity of variances, a two-sample t-test makes the assumption that the two samples have roughly equal variances. So the rule of thumb, if the ratio of the larger variance to the smaller variance is less than 4, then we can assume the variances are approximately equal and use the two-sample t-test. So that is how to check it. Suppose sample 1 has a variance of 24.5 and sample 2 has a variance of 15.2. The ratio of the larger sample variance to the smaller sample variance would be calculated as ratio 24.5 divided by 15.2 equals 1.61. Since this ratio is less than 4, we could assume that the variances between the two groups are approximately equal. And this is easy to use because we know even how to compute the variance in a manual way, right? You just use the mean of each of the group. You can have variance already. So this is easy to do. Now, what if no, you have violated? So what do you do? If this assumption is violated, then we can perform a Welch t-test. So it is still a t-test, which is a non-parametric version of two-sample t-test. So your research is still okay, and this does not make the assumption, the Welch t-test, that the two samples have equal variances. Now, the fourth assumption on random sampling, because this sample t-test, two sample t-test makes the assumption that both samples were obtained using a random sampling method. So to check this assumption, if it's met, there's no formal statistical test for this assumption. Just make sure that both samples were obtained through a random sampling method, which you as a researcher know, such that each individual in the population of interest had an equal probability of being included in either sample. Okay. Now, what if you have violated this assumption? Then it's unlikely that our two samples are representative of the population of interest. In this case, we can't generalize the findings from the two-sample t-test to the overall population with reliability. So in this scenario, it's best to collect two new samples using random sampling method. So of course, again, time, budget matter a lot. So by the way, I hear this normal distribution diagram. So just to understand better about the tail, one tail, two tails, the whole area, just a review, no, is equal to 1. Each half is equivalent to 0.5. This half. So this is 0 here, and then suppose that these are the labels here. Suppose this is okay. The negative side, this is negative actually, 0.025 area, 0.025 this right side. So this one is the one of the tails. Now, if you use both, it becomes two tails. So why we have this 0.025? Because actually it's on the level of the alpha level that you set, the researcher set for 0.05. So 1 minus 0.05, suppose you divide that into 2, the 0.05. So you have this 0.025 here, right side positive, and the left that is negative. So what's left after you deduct, you subtract, the 0.05 will be 0.95. So this area here will be the 0.95. Okay, and that will be, this one will be the area of rejection, and this one the area of acceptance. So if the p-value will fall here. So you are in the area of rejection, that you reject the null hypothesis, because usually the researcher will phrase the hypothesis in a null as a null. No, there's no relationship. So when you reject, so it means there is a relationship. Okay. Okay, so we are done with that video on assumptions. There is no corresponding exercise for that. I think that is good news for you. So let's proceed to the next input. By the way, you notice in that in the assumptions, as I've mentioned, the levels of measurement is really very important in the assumptions of any statistical tool, actually. Now, because you can't involve in those statistical computations if the level of measurement is just categorical, like a nominal, and if it's ordinal, like in terms of correlation, the ordinal can still be correlated, but it would be another form, that not a Pearson R correlation, but rather the so-called Spearman correlation. So it is only when your levels of measurement for the variables are at a continuous level, or the scaled level, that you can use the Pearson R, or the two sample t-test that we just mentioned. So let's now proceed to the t-test input on doing t-test with the use of Excel. So as I've mentioned also before, in SPSS, any statistical computation that you'd like to have very, very fast, in a blink of an eye, I tell you, even if you have 1,000 respondents, it doesn't matter, no? So massive data can be inputted in the SPSS and it will compute. If your laptop is some sort of advanced model with high speed, no, na laptop, so in a blink of an eye, it's done. If you use Excel, it's also doable, but it takes time. Okay, pangmasa jud ning Excel. Ang katong SPSS, pangmahalaga gyud to siya, kay dako siya og kuan. It's costly. Okay, so let me now proceed to the other input on t-test. It's about t-test that you are going to use computation. By the way, there is a corresponding exercise on this, and the data is the same from your university. Since there are two groups in there, so we can use those data sets for the t-test computation. So the t-test can be used in two group for the analysis of significant difference of two groups, or of the same group but in different times. Like for example, among those who receive health teaching for the College of Nursing there. So you can have a pre-survey and then provide health teaching to a particular community in community health nursing, for example. And you are going to have post-survey. And so you can use t-test to compare the pre and the post, factoring in, of course, the intervention that you have given, which is health teaching, and see if it is effective. so that there may be change in attitude or practice or behavior, something like that, in the community with regards to a particular whatever health concern in that community. Murag ingon anak siya, no? But the example, the exercise that you will be doing with regards to this t-test will be from parang two communities ni siya, no? Two communities with about 31 respondents, but it's okay as long as you reach 30, you can already have statistical computations. But based on experience, actually, no, the normal distribution is actually approximated well when you have bigger sample. If you have used among yourselves kana bitong sa man yung gipanggamit Sloven's formula, saan yung mga gipanggamit Cochrane's formula, whatever, no, there are so many formulas available na pay mga sample calculator, whatever it is. Usually when you are going to when your population will be over 1,000, usually the resulting sample will be about 400. So bisag pila na kalibo, like 1,000, 10,000, it will always be pegged at 400 respondents. So at 400 respondents, it is very highly likely that your assumptions will be met, especially kung you have conducted that in a random manner, no? Because heterogeneity is assured. So taas ang kuan. And I might mention di ay nga kanang sa ethics, sa research ethics committee di ay for those who have experience kuan ba applying for approval of the researches in the ethics committee or ethics board, because it is our mandate to look at the research ba beyond what is just ethics. Because why? Kuan manggod, the research can only be ethically sound if it is technically sound. That's why you may wonder, ngano hilabtan man putong sample, for example, anong hilabtan tong uban nga aspect of the research? Because maybe somebody, an expert in the ethics committee, might have diba, detected, found out sa badiha, no? Something to improve on the technical side. So research can only be ethically sound if it is technically sound. And a lot of technicalities are in the research methods, which is when if your research is quantitative, then the normal distribution is being looked upon. So let us have this t-test now. In this lesson on t-test, we are going to use in the computation the Microsoft Excel software. So the t-test function in Excel is used for calculating the probability of significant difference between two data sets, whether any or both of them are under the same population with the same mean. The t-test may be computed as a one-tailed distribution or two-tailed distribution with a kind of variance that may be equal or unequal. You remember I mentioned in that normal distribution, the 0.05 that you divide into 2, that will signify one tail or two tail. Now, the assumptions, going back as a review again, that the variables in the involved variables in the particular data set are continuous, and the samples have been randomly drawn from the large data, and there is normal distribution. In some books, it's referred to as Gaussian distribution. Homoscedasticity or homogeneity of variance. Variance, you know, that is computed as one of the measures of dispersion that made use of mean. Okay, and it's very important here in t-test. Now, these things to remember is that the t-test can accept only numerical values. Anything other than numerical values, we get the result this morning in a cell in Excel. If the tails value is other than 1 or 2, because the tail value is just either 1 or 2. So we will also get this error, and the Excel will not continue the command that you are giving it. And of course, you should learn the difference between one-tailed test and two-tailed test to understand it better. So the standard p-value is 0.05 or 5%. If the variance is less than 5%, then your data is significant. So the t-test function in Excel, when you already have opened the Excel software, then on your screen, you have the sheets that is composed of rows and columns. And on top of that, there's the pull-down menu, wherein one of the headings is formulas. Now you click that formula and you'll be shown statistical, these choices. You choose statistical and you choose t-test. Now this will be how it looks. No? Specifically, okay, in this particular formula for the t-test function in Excel is as follows. With these 4 arguments separated by a comma. Array 1, this is the first set of the sample you are testing. Array 2, this is the second set of the sample you are comparing. Tails, this is the number of tails for the distribution. There are 2 types of tails. One tail distribution, and two-tail distribution. So you just put either 1 or 2 in here, and usually we use 2. And the type, you are going to choose either of the 3 types. There are 3 types of t-test available in statistics. Okay, this one, paired. This examines whether the mean between paired sets is equal. If you choose this second, sample equal variance examines whether the variance of means between 2 sets is equal or homoscedastic. And the third one, 2 sample unequal variance examines whether the variance of means between 2 sets is unequal. It is heteroscedastic. In recent versions, t-test is introduced. In earlier versions, t-test is the formula. Still, it's available in recent versions to support compatibility. So now, how to use t-test function in Excel? T-test function in Excel is very simple and easy to use. Let us understand the working of t-test in Excel by some examples. But I've mentioned these 3 we're going to do. Now, the functionality of the t-test can be explained best by using an example dataset to get the logic of the t-test. Here are Group 1 and Group 2 tests, scores of a classroom. So, of course, these are total of the tests given. We are to run t-test to find if there is a significant difference between these 2 groups. Especially if you are going to say you are going to compare the group two groups or 2 sections, because there are 2 different teachers, or there are differences in the approach in teaching, or there is a module used in one and there's no module in the other, something like that. So apply t-test to get the difference. The first test is a type of paired. So this is what you're going to do. This is in sequence now after you have chosen t-test, and then you are in this portion, you are going to choose paired. Now the result is 0.04059. Okay, the result of this t-test. So that is how fast. Sometimes you just blink and it's there. That is how fast. The second type, yes, of two samples is of equal variance. So you choose this one, and the result is 0.2148. So there is really a difference. We are using the same data set, right? And that's the result. So the third test is a type of two sample t-test. This one, the two sample unequal variance or heteroscedastic. The result is 0.2158. Okay, this one. So we have now this corresponding results. The returned value is generally called as the p-value. If the p-value is less than 0.05, we can come to the conclusion that the two sets of data have a different mean. Otherwise, the two means are not significantly different from each other. Okay, have a look at that. This is the only one which is lower than 0.05, the paired. Now, okay. So in a closer look, the formula used, the paired, derive this p-value. The second, equal variance, this result, and the two sample unequal variance with this result. So as mentioned a while ago, if the p-value is below 0.05, then the conclusion is that the two sets of data have different mean. Otherwise, okay, the two means are not significantly different from each other. Okay. So we can run t-test using the analysis tool pack. At the same time, okay, what we did actually was based on the menu on above the screen of the sheet, right? So we can run the t-test also using the tool pack located under data ribbon tab, this one. So if you do not find this option in your Excel, follow the below steps to unhide these steps actually. So go to File and Options here. Click on Add-ins here. Then you're going to see this choices, and you are going to choose Excel add-ins. Go, and you have here these choices. You click on Analysis Toolpack, and you click OK, and voila, this must be enabled here in this portion. So when you click data, there is here data analysis. Okay. So if you click data analysis, you have these choices, and it will be easier when you are going to choose this mode of computation. So click on the first t-test, and it will open the below dialog box. This one, wherein you remember you can input the range, first range, second range, and here is the 0.05 value. Then where you want to the output to place, in the new worksheet or in the same worksheet. It's for you to choose. Just click it and then OK. So, okay. So just choose the range like that. And okay, the mean of each data set is shown. Their variance, number of observations, this one. Correlations, value. So once you do this, you are going to see all this. The p-value, you refer to this one, B26, this one, the p-value, that's 0.0001861102. That is below the expected p-value of 0.05. As long as the p-value is less than 0.05, our data is significant. So this is the detailed report from what we did here. So, hi. Okay, we are back. So I have prepared a corresponding exercise. Don't worry, because in that particular exercise there is also a guideline on how you do it. And in fact, it's actually it's spoon feeding, because I know that for you to be able to answer the exercise is you need to go back and watch again the video, which we don't have time for that. Okay, but in class it's like that. So they need to watch again the video lecture so that they can take notes and then they understand. But here, in the exercise that you're going to do, in the file, there is already a guide. And I've already specified the range of the data that you need to input. It's just for you to follow the guideline that I put in the Excel file itself. So again, you are going to open the Excel file that I'm going to put here the link, and you copy the whole answer. So do not round off, okay? So we cannot meet difficulty. But of course, in the actual research report, you are going to round off, and usually it's in the tenths, no? That dot and then a point and then 2 decimal points, something like that. But here, just copy the whole or the full answer from the cell to the Google form. So open Google form. The links I'm going to share. Okay, here you are. And Fisher-Fox data set for t-test workshop. That's it. And then you can open that now. You can begin working on that. And I'm going to also put on the link for the corresponding Google form to use. So it will be the 6th workshop of the day, but the first for this afternoon. Okay, so here is the link of the Google form. Okay, we are now 58. This morning we were 70. So now we are 58. 59, somebody got in. Welcome back. So looking at my laptop, there are 3 sheets. Containing the participants' names,
validity of the results, no, if that is acceptable. Usually mo na siya ang gina-raise sa ano.
Mga pila
Thank you,
ka,
ma'am.
sir?
Ang uban, ma'am, nara sa mga mall between 50 to 60, ana. So I think no, too small. Pero wala na option ang ano ma'am ba,
So
researcher
bali
because
actually wala na sampling ana na hitabo. It's called ko ana kanang
enumeration.
complete enumeration.
Complete, yes, complete enumeration. Because the setting was not expanded, for example, covering only 1 or 2 districts when in fact there can be more districts to include.
Pero bitaw sir, no, for me, if that is complete enumeration, all those data that's collected and the analysis that you are going to make will only be true to those districts.
Yes,
So
yes,
it's
correct,
okay.
ma'am.
There's
We
no
cannot
problem.
generalize.
Oo. Okay raman
Correct,
po
ma'am.
kay anyway since it's complete enumeration, so it actually all will describe
Be true
already.
only to the group.
Will describe the group in that kuan, in those districts.
Oo. Pero ang kuan mo good po ma'am, usually ang discussions sa researcher is that they also generalize given that they only have few samples. I mean, considering only that group, mo po na po ang ano pitfall. Another ma'am, with regards to assumptions, because I have read an article, because we need to satisfy assumptions for the parametric test, and I have read this article saying that there are some cases or instances that, for example, the assumption on normality is not satisfied, but the test still proceeded, and it was stated there that it can still generate valid results. So what's your take on this, ma'am?
Pila kay sample niya?
I think that's just a general ma'am. It was just stated sa iya lang to siya no, wala po ako nabasahan, so I do not know. It leads to confusion man good ma'am, because I know that we need to satisfy assumptions, but nabasa to nako ingon siya dito nga kung sa kuan pa two standard daw ko no, if everything is just in place so we can proceed with the parametric test. Pero in some cases daw sa real world daw ko no, lagi data nga true data, but ang tanang assumptions wala niya satisfy, but it is still okay to proceed with a parametric tests. And the results are still valid. So what's your take on this, ma'am?
But I think if you have bitaw, for example, na nakatong QQ plot, unya dili
Yes,
gyud siya, wala gyud siya diagonal
linear.
Bitaw. I don't think you can insist na valid imong kuan. So I think you better na lang non-parametric na lang.
Yes. Wag ito nakalibog check sa mut ba kay it was a claim, no? It was also a claim. And so, lastly, ma'am, yes, ma'am.
Di kay kung mag-non-parametric siya, wala na may problema actually dayon, di ba?
Yes, ma'am. I agree. And how about ma'am? What's your take about mga outliers? Kay for example, in preparing for the data, like ako, I personally noticed with that there are some outliers, and I think that the outliers can generally affect the distribution. Na murag dili na siya normally distributed because of these outliers. Are the outliers really needed to be? Do we need to delete, or are they all important para nga ato siya i-consider first for for the treatment?
Ang advice bitaw ana by some experts kay if your sample is kanang relatively okay, even if they are removed, i-remove na lang yun sila.
So it's a matter of if daghan na gyud ang sample size, so we can remove outliers.
Yes, mo na nga mas maayo, especially if nagakuan man kag statser, no. So kung naay mas okay gyud kung mo approach sa imo before pa mag-data collection.
Yes.
Mas maayo na siya kay imo siyang ma-advise. So for example, pila man ang iyang kuan sa sampling, unsa iyang sampling ba pila gyud ang result niya nga kuan desired sample. So moingon siya kuan kanang naa siya 200 no. So mas maayo kung imo siyang ma-advise nga magkuan na siya daan og kanang more than 200 tanang naay replacement bitaw.
Yes, ma'am.
mag 230 na siya for example. So naay 30 nga baka kuan excess siya. Ana. So in case lang nga naay mga outliers dito, mga naay incomplete data, so i-replace na
Replaced.
to sila.
Ah.
So 200 gyapon yang ending. Murag na bitaw.
So that's thank you ma'am for that suggestion. One last ma'am, in your experiences ma'am, how you encountered that there is a particular research output that you're asked to check because the ma'am being in the ethics committee, and you said a while ago that part also of your check is that the paper should also have uh, pass the technical requirement. So not a case in the past ma'am that none of research output, and upon checking you were able to find out that there were some issues no in that were not complied with. So what were your actions ma'am if what were your actions if you had the experience, or what will be your action if in case na ay mga certain let's say ethical issues nga wala na address sa ka-research and then implemented na ang study ma'am?
Implemented na.
Oo, because di ba na may practically there are some researchers ang makalusot no nga or means maybe no not properly, like for example in our case we don't have really the ethics committee who will check on the essentials no of how do we really have to conduct the survey, for example the issue on for example the conduct of the interview, the conduct of the data gathering. So in the end no nakita na nga medyo medyo kakulangon dito nga ato nga part sa iyahang timeline. So nana ang output, so how do we have to address if that is the case ma'am?
Okay, sa kung sa ethics committee gyud na siya no, ihatag unya done research na bitaw. But it's something that the ethics cannot kuan bitaw suggest anything kay unsaon pa man human naman. So dili gyud na siya matagaan og clearance sa ethics committee.
Okay ma'am.
Oo. Kay hands off naman kay what we issue clearance katurag yung wala pa, proposal pa siya. Oo.
Because supposedly ma'am no it has first to go to your office.
Yes.
Before the implementation.
Humana na defend sa nga thesis mo ato sa amo. Actually diha pod ang kuan kanang diha pod ang kanang napod baya. Kami manukupod mi kay pag-abot unsaon man gyud ni dapiyong ba sila ani pag defense kay ano klaro man kaining mga naay mga issues bitaw. Unya dapat human naman na sa technical. Unya mao naman dayon to nga alangan piyungan tani nakita man nato ni. So ibalik gyud namo unya naami ana nga kuan kay na Pinoy ta dili ta prangka para sa mga Amerikano nga bahala trabaho lang ni dili personalan. Usahay ang uban kay ma-feel gyud nila mas kabalo pa ba na sila sa ato murag something like that.
Mo lagi gid ma'am, that's mo gid ang usual problem pod nga a challenge pod na encounter pod not only sa amo but even in some other institutions.
Ikay ko kakuan okay. I'm a vice chair when I entered and I entered the committee. I was a vice chair and then I just became a chair because the chairperson died of COVID. So nahimo kong chairperson immediately kay kamera man gyud ang train. So nahimo na kong chairperson karon. But the chairperson before nag-ingon gid siya nako na naanay yang two friends nga nalain ang buot sa iya. So mo na akong kuna unsaon ang kaani ron lisod ang nasa ethics committee sa trula.
Yeah, I agree ma'am. Thank you very much ma'am for the replies. Very much appreciated. Thank you po. God bless ma'am.
Thank you and God bless you too. Napay question. Ay, okay. So am I to call sige question na. Wait, tanaw na ko na yung atong kuan. Naka-answer diri 49. 49. Okay na siguro ni. Nag-answer pa ba ang uban? So na mag-question. Okay. Amo na to si Sir Ariel, no? Si Sir Ariel na to. Okay, okay. Mana. Done na, okay. So, we will proceed. We will proceed to the next. Basta kay ang atong exercise on teachers, ang gagmay rag kuha diri katurang naka-Android. Sayo naman ni mag-compute pero katong sabay sa kuan gyud, no? Ang importante, you know what you are doing. You know that what you are computing subjected to the variables that you subjected to computation are really the appropriate variables. Oo na siya importante. So, let me share with you the last na ni. Last nga video lecture, it's just mga 13 minutes. This is now on correlation. But I think most of you have been using correlations already. So, kani nga correlations, this is for parametric kay kuan siya. Person R. I think you have been using person R already. So basta, if you don't satisfy the person R, you can use Spearman correlation. Kani. Module 10 is on bivariate data analysis. After you have done your univariate data analysis, you have already presented one by one the individual variables involved in your study. It's time to proceed to bivariate to find out if there is a significant relationship in any of the dependent and independent variables. So this is focused on Pearson R correlation. There are 4 areas that may influence choice of analysis, and you can determine by asking the following questions. What is the level of measurement? Remember, Noir? Are the data paired? Are they parametric? What are you looking for? Differences, correlation, etc. So each of these 4, we are going to tackle one by one in the next slides. What is the level of measurement? You let us mention again these 4 levels. So these are arranged according to level. So this is the lowest level, and this is the highest level. So ratio has the characteristics of those that below it. And so with interval and ordinal, the nominal has the most basic characteristics. So ratio and interval are continuous variables. You remember continuous variables? They are quantifiable. Ordinal and nominal are categorical or more on qualitative variables. The importance in knowing this is to make decisions about the type of statistical analysis that should be performed in your study. As arranged according to power, according to level. So nominal here, labeled as same or not, like male or female. That's the lowest level of measurement. Going ordinal, that's higher than nominal, so it has the characteristic of nominal. It is also labeled but rank this time. Example, second floor. So second floor is higher than the first floor, and so on. Interval higher than the ordinal, so it share the characteristics of both. It's labeled, it's ranked, and it's range. For example, a favor of 39 to 41 degrees centigrade range. Ratio, the highest of them all, is labeled, ranked, range, and zero. There is true 0 point. Like the 24-month-old baby, it's about age. So age starts at zero, same as weight and height. Are your data paired? Paired data are often the result of before and after situations. Before and after treatment, for example. Here, each research subject would have a pair of measurements. Look for a difference in these measurements to show an improvement due to the treatment. So before, weights of 30 children. Then, you introduce a month-long free feeding at a barangay health station where these children are going to eat um, feeding health, nutritious food for 1 month. Then you obtain the weight there after a month. So you already have, each respondent would have a pair of readings of weight before this treatment and after the treatment. This would be paired data. And we can name this for our purposes of computation. Before is X and after is Y. Are your data parametric? Ranks, scores, categories generally are non-parametric data. Measurements that come from a population that is normally distributed can usually be treated as parametric if it's normally distributed. Are you looking for differences or correlation? You have two sets of data. It may not always be a sensible thing to do, but you can do it. That there is a set of paired data, just like the example we had last slide. Look for correlation. Two sets of data where each data point in the first set has a partner in the second, like the weight of child 1 before and after, and so on. Consider these 2 points. Does paracetamol lower temperature? So you see here paired information. Does the number of exercises performed affect the amount of increase in muscle strength? Here, there are two variables involved. One, paracetamol, this temperature. Now, the question is, does paracetamol lower temperature? Here, number of exercises is a variable, and then muscle strength is another variable. So what does this number of exercises do with muscle strength? Which of this is about a difference and which is on correlation? The first, about seeing difference. Does this drug make a difference? Because does it lower temperature? The second, about correlation. Does the amount of exercise correlate with muscle strength? As you do more exercise, do you have more muscle strength? Bivariate data, we already mentioned, involve two variables paired together for analysis. Educational attainment, for example, is the first variable. Another variable is income. Are these two variables related? How? Like, does educational attainment in any way affect income? The relationships here are not cause and effect relationships. They only predict the behavior of one variable from the knowledge of the other variable. Illustration. First, as a person grows taller, it is expected that he will gain weight. Is there a relationship between height and weight? Second illustration. Students are constantly spending their time studying and taking exams while going to school. Is it true that the more you study, the higher your grade will be? So imagine this bivariate pairing, so two variables. Next illustration. Research doctors test new drugs. like the COVID-19 vaccine. Old ones too, by prescribing different amounts of and observing the responses of their patients. Does the amount of drug prescribed determine the amount of recovery time needed by the patient? Okay. So the linear correlation, does an increase in the value of one variable cause a change in the average value of the other? Pearson correlation coefficient, represented by letter R, can take a range of values from +1 to -1. So therefore, there's in between that is point point. A value of 0 indicates no association between the two variables. That's the result of the computation. A value greater than 0 indicates a positive association. Okay, like this one. If you are going to plot the two variables with the values, it will look like this for positive correlation. It will look like this for negative correlation. And if no correlation, it's as scattered as this. So this, there is somehow a formation of the values represented by these dots, the x-axis and the y-axis. Correlation will be considered high when it is close to +1 or close to -1, and low when it is close to 0, like this. So if R is zero point 0.7, looks like that, 0.3 like this, 0 like that. Okay, -3, there is a relationship but negative, so it will go like this. Going down, that is negative. Negative, but there is a relationship that is inverse. So if the correlation coefficients, the results of computations will be from zero point 0.9 to 1, that will be considered very highly correlated. 0.7 to zero point 0.9, highly correlated. 0.5 to zero point 0.7, moderately correlated. 0.3 to zero point 0.5, low correlation. Less than zero point 0.3, have little if any correlation. So this will be after you have computed everything and you will have this values or results. So this is how you are going to interpret. 5 assumptions of Pearson's are: the variables must be either interval or ratio measurements. Okay. The variables must be approximately normally distributed. Do first a testing for normality. The species will actually do this. There is a linear relationship between the two variables. And outliers kept to a minimum or removed when you see them. It will look like this. This is an outlier. You can remove. Homoscedasticity of data. It will be like this. Variances along the line of best fit remain similar as you move along the line. So the formula for Pearson R will be like this. It's a series of x and y, x's and y's. So n here, we know that n is for sample. So summation of xy, summation of x, summation of y. And there is this summation of x square and the summation of x, and then you square and so on. What does a positive value for r mean? A negative value, a value of 0. As x increases and the value of y increases, r value will be positive. Okay. The positive value of r, for example, age and height of children. As a children grows older, the height will also be taller. So that is positive or a parallel relationship. So both will go up. It's still positive parallel relationship even if both will go down. As long as the two variables will have the same direction. The negative value of r, age of automobile, as car ages, its value decreases. So there is opposite direction of relationship. It is inverse. So the value of that is negative. Okay. So given X is years in school and Y is tolerance score. Suppose these are the values of X and these are the values of Y. The N is 10. So each of the respondent will have X and Y values. So you are going to total this, total, and then you multiply X by Y, you put the product here, then X square, put here, Y square, put here. So this is how you are going to do it efficiently in a manual manner. You remember when we computed the variance? So we do this and it will be faster. Okay, so already computed. 2 times 3, that's 6. 2 square, that's 4. 3, 3 square, that's 9, and so on. And then you have the total here. And it's time to transpose. Okay, in the formula. So we already know that summation of xy, it's here. Summation of xy, you just copy. So n is 10 and 675. Summation of x is 79. Summation of y is 72. And then 10. The n is 10. Summation of x is square. We have value 761. Just put it there very fast. And then summation of x, that is 79 square, and so on. Okay. Then you follow IMDAS. First, you multiply this. You have 750. You multiply the two, 5688. And below, you also multiply this. You have this. 79 square, you have this, and so on. To continue, you have now 1062 over this one, values of this. You continue, you are going to have multiply this with the, and you have this result in a million over a million. And you obtain the square root. The square root of this, you have 1202. And now it's time to divide the final step. 1062 divided by this, and you have the value of r, which is 0.88. And where is that in the, if you are going to remember, recall the interpretation that will have a high correlation, right? Okay, that's the notices. So let us, so how to do that computation using Microsoft Excel. So you now have get given, okay, you now already have calculated this thing. So you have now the, or even if you don't have this, this is what we use in the manual, but you only need the X values and the Y values, okay? Type here, okay, the result you put here. So function here, you choose is statistical, then choose person. So you need to have person, okay? Person, there is array 1, array 2. Array 1, that's the X values. Array 2, that's the Y values. Returns the person, product, moment, correlation groups R, okay? Okay. So you specify the array 1. Array 1, that's all X. Okay, it's there. Array 2, that's all Y. And then okay. So you now have the result. Okay, so don't you worry, you are not going to compute manually. You are still going to use the Excel in the computation of uh, the correlation. So anyway, let me check on my on the file that you're going to use, because I remember I put there, it's not Pearson, but Corel. Let me check again. Pearson ba? Yeah, person, or Corel. Okay. Let me see if it's the same. Corel, is it person? Pearson. Oh, wait a while. Okay, I'm going to give you the correct one. Sanitaman 63, then E2. I'm going to use the Corel. B2, B, because I realized I've used another syntax in that video lecture. So let me check if it's the same. It's the same. Okay. Now the answers, and we'll give you the file. So either you use Corel syntax, the command syntax, or Corel. It will lead you to the same correct answer. So, hello, wake up, basing natulog na mo. So, naapa mo'y last na lang ni. Oy, last exercise. Sige, correct, tama ni. Can you, sige daw, B? Can I see some thumbs up? Are you still awake? Thumbs up. Ay, salamat, nagka na thumbs up. Awake pa di ay sila. 21, 20, okay. O, sige, naapa. Last na ni, di ba? Sige lang na, I think it's 3 o'clock. Nag-snack na sa siguro mo diha. O, di ba? Sana all, no? Katumanggong kuan, katumanggong akong gipakit. You're able to somehow learn from this webinar workshop that is really heavily loaded with exercises or workshop. No, just a short input, and then the workshop is somehow, diba, in various forms. No, 7 in all. So because I would like to address, diba, the skill aspect to match the knowledge aspect, because this is application. So I hope that you learned something from me, from those workshops that we had, and in a way you can still do them even after this webinar, and you are welcome to review the video lectures. It's just in my YouTube account. It's available there. Actually, daghan kaayo sa YouTube, di ba, no? But so that I also placed mine there for my students to access. But since I used it here, so pwede po ninyo to siya re-access if you want. And thank you for this opportunity to share what I've learned, because I believe that what we know as educators, we should share to others so that it will be multiplied to our students. So thank you, MU. Thank you, Russell.
Thank you so much, ma'am. Thank you so much, Dr. Mary Ann Daklan. And now, at this point in time, we will be giving the award to our distinguished speaker for this afternoon's webinar workshop. Okay, so this certificate of recognition is awarded to Dr. Mary Ann F. Daklan for sharing her invaluable time and expertise as a resource speaker on the webinar workshop on using appropriate statistical tools in quantitative data analysis for social science research via Zoom on August 12, 2021. Given this 12th day of August 2021 at Misamis University, Ozamis City, Philippines, signed by the university president. Thank you so much, Dr. Daklan, for a very informative and interactive presentation. Okay, so at this point in time, before we leave, so earlier everybody has answered and did the activities, and our resource speaker told us that there will be prizes for those who answered and those who got perfect scores. So I already have here the list of the names for those who um, consecutively got perfect scores for the workshops that you have that we had earlier. So there are six winners. Yes, there are six winners. We have here the for the first place. Um, I mean, all of the winners will be receiving loads. For the first place, he will be receiving 150 worth of load. For the remaining places, they will be receiving the same amount of load, which is 100 worth of load. Now, I will be announcing the winners of um, the winners for the workshops now that you had earlier. So for the first place, congratulations to Mr. Raj Compo. Okay, let's give him a hand, please. Mr. Raj Compo is our first place, so he will be receiving 150 worth of load. For the remaining places, we also have here Mr. Raywell Entera. Mr. Raywell Entera will be receiving 100 worth of load, together with Miss Jessa Rial. Miss Jazariel will also be receiving the same amount of load, which is 100. And also we have Miss Michelle Rose Kayasan. We also have here Dr. Ariel Clarin and Miss Maricar Mutya. Okay, so they will be receiving 100 worth of load. So the people here are already cheering. Congratulations for those who will be receiving their loads as per instruction. I was told that those who won the loads, please type down your phone numbers in the chat box so that we would be able to you will be able to receive your loads later.
The other
Okay,
one
so
is Ma'am Motya. What's the name?
yes, ma'am, Miss Maricar Mutya, ma'am.
I can't find her name in Maricar Motya. Maybe using another Zoom name. I
Yes,
want the
ma'am. As
spotlight.
yes, ma'am. She is using another Zoom name now.
What's the name here in the Zoom? Para atong makuha.
Okay, we are just trying to verify it now.
Ay ma'am, unsa imong name dire?
Ma'am Maricar Mutya, may we know what account you are using?
Kay mag ano ta? Na may pictorial screenshot style.
Yes, ma'am.
Na ng mga nakadaog. Na nilang mga number.
Congratulations to
Ana
all the
Bonita,
winners.
ang iyang name.
Okay.
Okay ra ni nga Ana Bonita imong name? Dire atong ibutang og Maricar Mutya. Yes. Okay, screenshot na ninyong mga winners. Or you can show yourselves in the, you can turn on your
Okay.
camera. Murag ka na
Okay.
bito magpa-picture ta sa inyo, ha?
Okay, teachers, shall we open our cameras
Sige. Kanang mapa-picture
for
bitaw.
documentation?
Oh. Di ba? Documentation is sa research office.
Yes, ma'am.
O pag screenshot na mo diha. Maoning mga dagkog scores. O di ba? You should be proud of yourselves lagi.
Congrats.
Ma'am Maricar. Nursing department. O kung man nakita ang uban. Si Jessa. Basta ngalan, na din ha. Kinsay mo picture? Sige, mo picture ko. Taga na ako sa taga naman may Google Drive. Sige, 1, 2, ready. Di ka magpakita, research office?
Research office daw.
Ma'am Russell.
Ma'am Russell, wala kayo PN?
Okay.
Kasi magpakita kay 500 ang i-load.
Tamo ka kayo. May budget, Sir Arnel.
Oh,
Hindi ba open?
sige, atong o kana. Makita na mo sa taas. Okay, sige, appeal si host. Sige. 1, 2, ready, smile. Yan. Ako rin yung ipadala sa kuan. Ibutan ako sa Google Drive.
Okay, ma'am. Thank you so much, ma'am. By the way, before we leave, I would like to inform everyone about the evaluation form. I guess it was already sent here. Ma'am Russell. Okay, Ma'am Russell will be sending the evaluation form for this afternoon's webinar workshop. Today's webinar workshop. Okay, here it is. It's already in the chat box. So for you to access it, just open your chat box, teachers. Okay, Mom Russell, do you have something to say before
Okay, so
we
thank you,
conclude?
sir. So I would like to take this opportunity to thank everyone for making this webinar workshop a successful one, especially to the participants who have actively participated in the exercises, and to our energetic MC, Sir Jerry Hakusalem. Thank you so much, sir, for hosting our event today. And of course, to our ever dynamic and spontaneous speaker, Dr. Mary Ann Daklan. I can't thank you enough for agreeing on my request to be the resource speaker for this webinar workshop. You indeed made statistics simplified and an enjoyable one. So thank you so much for sharing your knowledge. God bless us all. Thank you, everyone, and keep safe.
Okay, so that concludes the webinar workshop for today. Thank you once again, Dr. Mary Ann F. Daklan, for such informative and interactive webinar workshop. Okay, once again, thank you so much, everyone, and congratulations for finishing the webinar workshop for today. This has been your moderator, Jerry Amakasalan Jr. God bless and be safe, everyone. Thank you, ma'am. Okay, for those who were unable to access the evaluation form, again, it's already available in the chat box.
Jerry,
Thank
ako na kang
you.
gi-host, so I will leave and then kamo na lang mabilin. Ikaw
Okay,
na
ma'am, no
mag-off sa
problem.
Zoom. Okay,
Okay.
bye-bye.
Bye, doctor. Keep safe. Thank you so much.
Thank you, Ma'am Ann.
Welcome.